Welcome to ETE MCQs. Now let us solve a problem. Given a sequential circuit, it is constructed using JK flip-flop. The flip-flop is positive edge triggered. The input to J and K is determined by the AND gate, which takes A, B and C as input. And the input to the K input of JK flip-flop is driven by this AND gate, which takes X, Y and Z as input. So the question is, for the given sequential circuit, determine the output sequence. So we are given a sequential circuit and we are asked to find the output sequence. So before we proceed further, let us just have a recap on the truth table of JK flip-flop. Two inputs, J, K, and the output is represented by Q of n plus 1. Since it is a positive edge triggered flip-flop, only during the passage it will have an impact. The passage is represented by a. So since you have J and K, two inputs, there will be four possible combinations: J0, K0, J0, K1, J1, K0, J1, K1. If J and K both are 0 at the particular edge triggering, if J and K both are 0, the previous output will be maintained. Whatever may be the previous output, if the previous output is 0, the output remains 0. If the previous output is 1, the output remains 1. When J is 0 and K is 1, at the edge triggering, Q of n plus 1 becomes 0. At the next passage triggering, when J is 1 and K is 0, the output becomes 1. For J and K both are 1, at the particular edge triggering, Qn, the present state toggles. Whatever may be the value of Qn, it toggles. If Qn was 0, it becomes 1. If Qn was 1, it becomes 0. That is what I mean by toggle. The output, the present output toggles. K. J and K totally depends on A, B and C. J depends on A, B and C. And K depends on X, Y and Z. So based on the table that is given for us, the values that is given for sequence of values that is given for A, B and C, as well as for X, Y and Z, let us try to trace out what will be J and what will be K. The sequence of values that will be given as input to J can be traced from the values of A, B and C. A, B and C, all the three are given as input to an AND gate. Okay, so for 101, the output of AND gate will be 0. For 011, the output again, the sequence of J remains at 0. For 111, it becomes 1. For 011, it is 0. For 000, it is again 0. For 100, J is again 0. Again for 110, it is 0. And for 100, it is again 0. Likewise, for K input, you will have the sequence from based on X, Y and Z. For 011, it is 0. For 010, again it is 0. For 001, it is 0 again. For 110, again 0. For 111, it is 1. For 100, it is again 0. For 001, it is again 0. So the possible values of J and K are sequence of values that J and K will take as input is obtained. In the transition table, you will have J, K and the respective output Q. Initially, let us assume that all the flip-flops are reset so that clear is enabled irrespective of the value of J and K. Q of n plus 1 is 0. This is the initial case. Now let us just, for each and every edge triggering of the clock signal, let us just try to find what will be the output sequence. Let us assume the output to be 0, that is the clock signal is enabled to reset the output of the flip-flop. Now this Qn plus 1 is nothing but this particular output, okay, which is represented as Q. Now Let me just write the sequence we have for J. The J sequence is 0, 0, 1, 0, 0. Now for 0 and 0, you can notice that when J is 0, K is 0, from the truth table, you can notice that the previous output is preserved. So Qn plus 1 remains 0. Again for 0 and 0, it remains 0. When J is 1, K is 0, the output becomes 1. For 0 and 0, the previous output is maintained. For 0, 1, the output becomes 0 because K is 1 and J is 0, the output becomes 0. For 0 and 0, the previous output is maintained. Now you can notice that the output sequence Q is given as 000, 11, and then again 000. So you can notice that the first option is correct. If you ignore the initial clear signal, and then if you notice this part is fine. We have taken a clear signal that if you just isolate it, you can just notice 00, 11, 000 is the right option. Thank you.